All right, accelerated pre-calc lesson 4.2. So this is day one of the unit circle, and we're going to focus on the unit circle and working with degrees, okay, angles and degrees. So before we do that, let's review some really important geometry that you need to remember from last year. First of all, the 45, 45, 90 right triangles. Remember the legs are equal, right? So whatever one leg is, the other leg is the same. And if you know the leg and you want to find the hypotenuse, you just multiply by radical 2, okay? Now let's say you know the hypotenuse and you want to find the leg, you just divide by radical 2, all right? Our 30, 60, 90, right? Remember the most important leg in a 30, 60, 90 is the short leg, and the short leg is opposite of the 30-degree angle, okay? So this here would be the short leg right here. So if you know the short leg and you want to find the hypotenuse, all you do is take whatever the short leg is and multiply it by 2. If you know the short leg and you want to find the long leg, all you do is take the short leg and multiply by radical 3. Okay? Now if you don't know the short leg and you have one of these, right? Let's say you know the long leg. If you know the long leg and you need to find the short leg, you would divide by radical 3. And if you know the hypotenuse and you need to find the short leg, you would divide by 2. Okay, so those were our rules for our special right triangles. Okay? Next thing, our trig ratios, sine, cosine, and tangent. Right? So we learned that sine was opposite over hypotenuse, right? Opposite over hypotenuse. Cosine was adjacent over hypotenuse. And tangent is opposite over adjacent, right? And that's where the SOHCAHTOA comes from, right? Remember, this helped you set up these trig ratios, right? This is kind of a saying. Now, the reciprocals, right? The reciprocal trig ratio for sine is cosecant, okay? The reciprocal trig ratio for cosine is secant, and the reciprocal trig ratio for tangent is cotangent. And all you're doing is you're taking these and you're flipping them. So, since cosecant is reciprocal with sine, it's hypotenuse over opposite. And secant is reciprocal with cosine, so it's hypotenuse over adjacent. And cotangent obviously is reciprocal with tangent, so you just flip that, adjacent over opposite. Okay. One thing you should remember that the reciprocals, they don't start with the same letter. A lot of times students mix up the reciprocals. They'll think sine and secant both are reciprocals, right? Because they still both start with an S. That's incorrect, right? Just remember that reciprocals, they start with a different letter. So that way you don't mix up cosecant and secant with their reciprocals, okay? So tangent and cotangent, that's pretty obvious. So just remember the reciprocal of sine is cosecant, the one that doesn't start with the same letter, okay? So that's all the kind of geometry that we need to review. So let's get into doing some of these unit circle problems. All right, so let me review some really important things to remember. First of all, we have to remember that the x-axis, right? The x-axis here is represented by cosine, right? The x-axis represented by cosine, and the y-axis is represented by sine, right? So right here, so let's say I have this right triangle, and I'll prove to you why it is the way it is. So say I have this right triangle, right, and with the angle theta. Now this is a unit circle, right? So the radius of this circle is 1. So the radius here is 1, the radius here is 1. Right here, the hypotenuse of this triangle, that's also 1, right? So let's say I need to find the cosine of theta, right? So this angle here. Well, cosine is adjacent, which is x, over the hypotenuse, which is 1. So we're going to end up with cosine theta is equal to x, okay? Sine theta. Sine is opposite, which is going to be y, over our hypotenuse, which is 1. So sine theta is equal to y. So that's why cosine is represented by x and sine is represented by y. Okay? So this coordinate here, right? So this coordinate here on the unit circle from this point, so the coordinates of this point right here. So the x value, that is the cosine, and the y value is the sine. All right. So to get to this point here on the unit circle, you move to the right whatever x is, and then up whatever y is, right? It's kind of like just moving, on a Cartesian plane. So from this, we can determine that, hey, tangent theta, tangent we know is opposite, right, which is y, over adjacent, which is x, right? So tangent by definition is y over x, which is equivalent to sine over cosine, right? So we'll use this one later, right? But just remember, tangent theta is y over x, all right? And all that is right here in your notes that I provided for you, okay? Okay, so here is the unit circle all filled out and everything. So today, basically what's happening is you're going to learn where these coordinates come from, right? Like how do these coordinates come about, okay? And we're going to focus just on degrees today, right? On the following class, I'll teach you how to find these values using radians. But today we're just going to focus on degrees, all right? So you're going to learn where these coordinates right here, right? Where do they come from, or how do they come about, okay? And some really important values to remember are 90 degrees, 180 degrees, all right, 270, and going all the way around, we know obviously is 360, right? And when you go all the way around the circle, that would be considered 360 degrees, okay? And since this is a unit circle, the radius is equal to 1, right? So some key coordinates to remember, right, are the ones right here at 0 or 360, right, at 90 degrees, at 180 degrees, or 270 degrees. So these coordinates here, and you really don't need to memorize them because it's kind of obvious. You just remember it's a unit circle. So at 0, the coordinate is 1, 0. At 90, it's 0, 1. At 180, it's negative 1, 0. At 270, it's 0, negative 1. So remember these values because they're going to be important, okay? So let's do some examples so you guys understand what we're going to do. Okay, so I'm going to do number 1 right now. So we need to find the cosine of 60 degrees. So what you're going to do first is you're going to sketch 60 degrees. So 60 degrees, right? So remember, this is 90 degrees right here. So 60 degrees is going to be about right here, right? That looks like it's about 60 degrees. So what I've just sketched a 60-degree angle, right? Right here. Now, what you're going to do next is you're going to form a right triangle by dropping a perpendicular line, all right, to the x-axis, right? Always to the x-axis. So I'm going to make a perpendicular line to the x-axis so that I form a right triangle. So now this makes a right triangle. So we've got 90, 60, so this angle here is going to be 30. Now right here, this is a radius, right? And remember, our unit circle, the radius is always 1. So this is 1 right here. Well, using our 30, 60, 90 rules, if the hypotenuse is 1, the short leg will be 1/2, and the long leg is going to be radical 3 over 2. Okay? So for the unit circle, the nice thing about the unit circle is these values are always going to be the same for a 30, 60, 90 right triangle. The hypotenuse is always going to be 1 because that's the radius of the unit circle. These values will always be the same, right? So opposite of the 30 will always be 1/2. Opposite of the 60 will always be radical 3. But sometimes they will be positive, sometimes they'll be negative, depending on which quadrant we're in, right? So at this point right here, right? This point right here in quadrant 1, we know the x values are positive. The y values are also positive. So these are positive, okay? So we need to find cosine 60. So here's how you do that. So cosine 60 degrees, right? We know cosine is adjacent over hypotenuse. So from this 60-degree angle, central angle, right? What's the adjacent side? The adjacent side is 1/2. And the hypotenuse is 1 divided by 1. So we get what? 1/2. And that's your answer. So cosine 60 degrees is equal to 1/2. Okay? Now, I want you to understand what you've found here and what you've done. Basically, this point here, right, this coordinate on the unit circle. So this point here, the coordinates of this point is 1/2 and rad 3 over 2. right? 1/2 and rad 3 over 2. So like if you want to get to this point from 0 when you move over 1/2 and go up radical 3 over 2. So these are the coordinates of this point on the unit circle, right? And remember cosine, cosine is represented by the x value, the x-axis. So look at the x value right here. It's 1/2, right? Same thing as our answer. All right, so let's do number 2 here. So number 2, the angle is negative, right? So if the angle is negative, remember we're rotating clockwise, right? So when the angle is negative, we rotate clockwise. When the angle is positive, right, we rotate counterclockwise, right? So right here, here's negative 90 degrees. So negative 150, we've got to go another 60 degrees, right? So I would say maybe about right there, okay? And then let's drop our perpendicular to the x-axis, right? Always to the x-axis. Now, if this angle right here, right? If this angle here is 150, and it's negative because we're rotating clockwise, that means the rest of this angle right here, this small angle left over here, has to be 30 because remember halfway around the circle is 180 degrees, right? So we've got another 30, 60, 90 right triangle, right? So we know that opposite of the 30, right? So our radius right here is always going to be 1, right? Because it's a unit circle. Opposite of the 30, so we know that's going to be 1/2. Opposite of the 60 right here, we know that's rad 3 over 2. And then over here in this quadrant, right? This point here, this coordinate, we know the x values are negative, right? And then we know the y values are below right here. So that's also, y values are also negative, right? So then now let's find cosine negative 150. Well, cosine we know is adjacent over hypotenuse. So relative to this central angle right here, right? So we're using this angle right here. So from this angle, what's the adjacent side? Oh, it's negative rad 3 over 2 over our hypotenuse, which is 1. So our answer, cosine negative 150, is negative rad 3 over 2. Okay? And like I said before, this point here, what are the coordinates of this point? Well, you move to the left on the x-axis, how much? Negative rad 3 over 2. And you're going down negative 1/2. And you notice cosine, remember cosine is represented by the x value, or the x-axis, right? So look at our x value at the coordinate. It's negative rad 3 over 2, right? So let's take a look at number 3 next. All right, so I'm going to do number 3 now. So number 3 is a little bit different, okay? Because we're asked to find the secant at 180, okay? So there are the 4 special points that we know right here, right? So right here at 0 degrees or 360, right? Over here at 90, over here at 180, over here at 270. Anytime you're asked to find any trig ratio at any of these values here, right? You don't need to make a triangle because you know what the coordinates are already at these values. Like at 0 here, the coordinates are 1, 0. At 90, the coordinates are 0, 1. At 180, the coordinates are negative 1, 0, right? At 270, the coordinates are 0, negative 1. So just remember at these 4 points here on the unit circle, if you're ever asked to find any trig ratio at any of these degree angles, right? Then you don't need to make a triangle because you know what the coordinates are at these values, right? At these measurements, okay? So we need to find secant 180. So secant 180 is right here. So we're using these values right here, right? So we're using negative 1 and 0. So remember, this is your x, this is your y, right? So secant, right? Secant is reciprocal, right? With which trig ratio? Hey, it's the reciprocal of cosine, right? So here, the cosine value is the x value, right? So cosine at 180 is negative 1. So cosine at 180, right, is equal to negative 1. Well, secant, remember, this is just the reciprocal. We just flip this, right? So negative 1 is the same thing as negative 1 over 1. If you take this and you flip it, that's just going to be 1 over negative 1, which is still going to be negative 1, right? So that's secant 180, all right? Now let me give you another example of this. Let's say we need to find, hey, what's tangent 270. Tangent 270 is right here, right? So tangent is, by definition, y over x. Remember we established this earlier? So what's the y value at 270? The y value is -1. What's the x value? The x value is 0. Can we divide by 0 in math? No. So we know that tangent 270 is undefined. Okay. Let me do another one. So let's say over here at 90, what's cosecant? Let's say what's cosecant? 90. Okay. Cosecant is reciprocal with sine, right? Is reciprocal with sine. So we know at sine 90, sine of 90 degrees, right? That's the y-axis. Remember, sine represents the y. Sine of 90 is equal to 1, right? So 1 is the same thing as 1 over 1. So cosecant, you flip this, so you flip the 1 over 1, so it's still going to be 1. Okay? So anytime you're asked to find any trig ratio at any of these 4, right, angle measurements, right, then you're just using these coordinates here. There's no need to make a triangle. Okay. All right, so let's take a look at number 4 here. So number 4, we're given the angle in radian. Okay, so let's use our conversion and change this to degrees. So we know that if this is in radian, if we need to change this angle to degrees, we multiply by 180 over pi. So the pi's cancel. 6 goes into 180 30 times. So 30 times 11 gives you 330. So this, all right, cosine 11 pi over 6 is equivalent to, it's the same thing as cosine 330 degrees. Okay, so let's sketch that now. Let's go cosine 330 positive. So since it's positive, we're rotating counterclockwise. Here's 90, here's 180, here's 270, and then 330. So if this is 270, 330, you need to go, what, 60 more? So let's say about right there. So this rotation here is 330 degrees, right? So we know the rest of this angle right here has to be 30 because the whole circle makes 360, right? Drop a perpendicular to the x-axis, right? So we've got another 30, 60, 90. So the radius or hypotenuse is 1, so opposite of the 30, it's going to be 1/2, and it's going to be negative because the y values are down here are negative, right? So y values down here, right? Opposite of the 60 is rad 3 over 2, right? And positive because the x values are positive over here on the x-axis, right? And then what are we finding? We are finding cosine. So cosine of 330, well, cosine is adjacent over hypotenuse. So what's adjacent to this angle right here? Rad 3 over 2 over 1, which is our hypotenuse. So we end up with rad 3 over 2. Okay? And like I said, the coordinates right here, our x is rad 3 over 2, y is negative 1/2. And you notice cosine is represented by the x, all right? Represented by the x, right, coordinate. So rad 3 over 2, and that was our answer. Okay? Let's take a look at the next one. Okay, so number 8 here. We're going to jump to number 8. So if you don't have a diagram, here's how I would sketch it. So first make a x and y axis, right? And now we need to sketch negative 225. So since it's negative, that means we're rotating clockwise. We're going to rotate clockwise. So here is negative 90, negative 180. So we got to go another negative 45. All right, so we got to go another negative 45 right here. And then that will give us our triangle. So here's our right triangle. So since this here is negative 180, so we rotated another 45 degrees, right, to get to 225. So this would be 45. And the fact that it's negative or positive doesn't really matter. We just need to know the value so we can find these side lengths. So our hypotenuse, remember that was the radius of the circle, right? So that's 1. Well, if this is a 45, 45, 90 right triangle, right? If you know the hypotenuse, to find the leg, you divide by radical 2. So you take 1 divided by radical 2, well, that's going to be 1 over radical 2, and we rationalize it. So we end up with radical 2 over 2, right? So this is radical 2 over 2, and radical 2 over 2. All right. So remember, for a 45, 45, 90 triangle in the unit circle, since the hypotenuse will always be 1, just remember the legs are always going to be rad 2 over 2, and they're the same since it's a 45, 45, 90 right triangle. Now just be careful, sometimes these values will be negative and positive depending on where you're at. So in quadrant 2 here, we know the x values, right? Over here on the x-axis, x is negative, but y is positive. So that would be positive, this would be negative. Okay, so we're finding sine. So sine, we know, is opposite over hypotenuse. So from this central angle, the opposite side is rad 2 over 2 divided by our hypotenuse 1. So we're just going to get rad 2 over 2 as our answer. Okay, so just remember, in the unit circle, you should always, when you're making these triangles, they should always be a 45, 45, 90 or 30, 60, 90. If you're getting anything else, then obviously something's wrong. Okay, so let's look at the next example. All right, so cotangent negative 240. Okay, so once again, let's draw our angle. So since the angle is negative, we're rotating clockwise. So here's negative 90, negative 180. So negative 240. All right, so 180, you got to add another 60. So we're talking about, about right here. So draw our perpendicular to the x-axis, always the x-axis. So if this is negative 180, right, this rotation, we've gone another 60, right? We've gone another 60 to get negative 240, okay? So then our hypotenuse is 1, because that's the radius of the circle. And then, well, opposite of the 30, that's going to be 1/2. Opposite of the 60, this is rad 3 over 2. And in quadrant 2, we know the x's are negative, but the y's are positive, right? So we're finding cotangent. Now cotangent is the reciprocal of tangent, right? And we know tangent is opposite over adjacent. So we know cotangent is going to be adjacent over opposite. So relative to this angle, right, the adjacent side, negative 1/2, divided by the opposite side, rad 3 over 2. Well, this is the same thing as taking negative 1/2, multiplying by the reciprocal at the bottom, 2 over rad 3. So these cancel. So we get negative 1 over rad 3, and then you rationalize it. So we're going to end up with negative rad 3 over 3. Okay? All right, so let's take a look at an example where we're rotating around, all right, more than one circle. More than once. So cosine 660, right? So basically what this means is we're going to go all the way around the circle once, right? All the way around once. And then we have to go around another 300 to get a total of 660, all right? So what's happening is, so I'm going to show you the rotation. All right? So we go all the way around one time. That's 360, right? So we're back to where we started. And then we have to rotate another 300, which would be about maybe right here, right? So essentially what that means is cosine 660 and cosine 300 is the same thing, right? Because if you go all the way around the circle, all right, one time, 360, you're basically back at 0, right? So basically what we've done is we've rotated around, right, all the way around 360, then we rotate around another 300, right? So since we went another 300, right, that means this angle here has to be 60, right? Because 300 plus 60 will give you the 360 for a full rotation, okay? So our radius is 1, right, which is the hypotenuse. So the 30 is here, so opposite of the 30, that's going to be 1/2. Opposite of the 60, rad 3 over 2, right? And over here, in this coordinate, in the quadrant 4, these coordinates, y is negative, right? But x is positive. Cosine is adjacent over hypotenuse. So adjacent to this angle right here is 1/2 divided by the hypotenuse, which is 1. So our answer is going to be positive 1/2. Okay, let's take a look at another one. All right, so let's take a look at secant negative 495. Okay, so let's draw our two axes. And then negative 495, so we know we are going to be rotating, since the angle is negative, we are rotating clockwise. So basically what you're doing is you're going to go all the way around, right? That'll be negative 360, right? So if you go all the way around, right, so negative 360. So how much more do you need to go to get to negative 495? You need to go another negative 135, right? So this will be a total of negative 495. So then we're going to rotate, all right? So we went all the way around, right? We went all the way around, that's negative 360. Then you got to go another negative 135. Here's negative 90. Negative 135 is going to be right here, right? And then let's draw our triangle. So if this is 135, right? This missing angle right here has to be 45 because this is 180 right here, okay? So then we've got a 45, 45, 90. The hypotenuse is 1 because that's the radius. So these two side lengths are going to be rad 2 over 2 and rad 2 over 2. And over here, x's are negative, y's are also negative, right? So we're finding secant. Secant is reciprocal of cosine, right? So all you're doing here is secant, we have cosine, which is adjacent over hypotenuse. So secant, we're doing hypotenuse over adjacent, right? So hypotenuse is 1. Our adjacent to this angle here is negative rad 2 over 2. So 1 divided by negative rad 2 over 2 is the same thing as 1 times negative 2 over rad 2. So basically we just need to rationalize this. So we get negative 2 rad 2 over 2. So the 2's cancel, divide out. So our final answer is negative rad 2. Okay? So let's maybe do one more. Alright, so we need to find secant 3 pi over 2. So first of all, remember we want to work only in degrees for this lesson. So let's convert this to degrees. So we have to multiply by 180 over pi. So the pi's cancel, 2 and 180 reduce, that'll give you 90. So it looks like we're going to get secant 270, right? And you should recognize, hey, 270, that's one of those special coordinates, right? That's basically right here on the unit circle, 270 degrees, right? So the coordinates there are, remember, 0 and negative 1, okay, at 270. Now, secant is the reciprocal of cosine, right? So cosine, you know, is the x value at this coordinate, right? So if you're finding the secant, so cosine, so basically think of it this way, cosine 270 is 0, right? 0 is the same thing as 0 over 1. If you're finding secant of 270, you're just going to flip this. So that's going to be 1 over 0. Can we divide by 0? No. So we know our answer is going to be undefined. Okay?